Hi, so we go for the first learning unit, which is mapping and survey. So basically, what is survey? So surveying is about the different ways of collecting information and the knowledge. As you can see here, it could be through the data entry, it could be through the qualitative, or in GIS, we use some sort of survey methods. So we go to definitions. The surveying and mapping is a science and art as well as technology of determining the relative positions of points above, on, or beneath the Earth's surface, or of any establishing such points. Meaning to say that for the survey and mapping, they are methods, they are techniques, they are steps, which is science. And we will trying to put it into a graphic, a map, which is an art, and as well as we used new technologies such as drones, satellite images, cloud applications to determine the relative points. So any points that have informations, okay, of points above, meaning to say it could be points that are above of the Earth's surface. It could be within our atmosphere. It could be on the surface, which is on the ground. Any points, such as survey points, cadastral maps, cadastral points, could be points of the trees, the infrastructures, and also it could be beneath the Earth's surface. Somewhere, somehow, it is down on the Earth's surface within the Earth crust, such as the survey for the oil explorations, mining, and more, or of any established points that we have around us. And more definitions about this. So survey mapping is a discipline which encompasses all methods for measuring and collecting informations about the physical earth and our environment, where all the informations that have been collected and also be measured will be processed, the informations, and also we will try to disseminate the informations through a variety of resulting products to a wide range of clients. So meaning to say here, it could be any type of methods. It could be quantitative, it could be qualitative, scientific, it could be somehow informal, where all of these will be measured, will be quantified, and all the informations is all about the physical earth. Anything physical, anything tangible within our earth, as well as our environment, the phenomena, the incidents that occurred surrounding us, where it will be processed into a secondary and tertiary informations. And the idea of all of these informations we collected is to disseminate these informations to a variety of different products. It could be in consumptive products such as mapping, the hard copy of mapping, or it could be in forms of digital format, such as within the global earth or global maps, could be through the websites, applications, cloud applications, and more. And it is to a wide range of clients. It could be beneficial for most of the agencies, including government and also private agencies. So the International Federation of Surveyors defines surveys as the determinations of the size and shape of the Earth and measures of all data needed to define the size, position, shape, and contour. This is what we know as a geodetic survey. In other way, it also could be the positions of the object in space and positionings and monitoring of the physical features, structures, and engineering works. So this is about the engineering survey. So these examples of why we use survey in our daily operations or daily activities to observe the dam stability in a millimeter scale, tunnel constructions where we can't use any GPS within beneath the earth surface. So you use the survey, bridge constructions, and many more. And another definitions is to determine the positions of boundaries of public and private land, including the national and international boundaries, and registration of the lands within appropriate authorities. This is the cadastral survey. So examples here, okay. And of course, as I said before, we use new technologies, we use computers, we use applications. So the design, establishment, and administer the land and geographic information systems, and the collection, storage, analysis, and management of the data within the system. This is about the geographical information system, where we will digitalize all of the data, keep it in database system, and display it through the graphics. Of course, they are study of the natural and social environment to measure the land and marine resources, the use of data in planning of development in urban, rural, and regional areas. This is all about the geodesy, hydrography, and land use planning, development planning as well. So those surveyors, those planners, town planners, urban planners, as well as social planners, they also use GIS in order for them to analyze the data, to keep and to analyze the data. Another thing will be the study of the biological distribution and population of animals and vegetations, determinations of soils and geological minerals to manage resources and sustainability. This is all about the soil survey, environmental planning and management. That's why if you ever, some of you might came from this plant science or aquatic science, you also learn GIS, where you learn on how to use GIS in managing the resources from the bird's eye. Planning development, redevelopment of the property, whether urban or rural areas. So this is about the town and regional planning, property management, assessment of value and the management of property. So this is a property management, planning, measurement, management of construction works. This will be the quantity survey, building survey, and a lot more. So the idea of having all of this technology, especially the GIS, is we want to map the earth. We want to map our regions. Why? It's because that we want to have a bird's eye view from above, so that we can easily figure out any physicals which is seen or could be indirect, direct or indirect properties on the map that we can analyze and also give us informations. So map allows us to see the world and its features on a piece of paper So that's the idea. It is scalable, it is easy, mobile, and it can give a lot of informations, direct and indirect. And of course, the production of maps, files, charts, reports, this is all about the geomatics and so on. So why we do the survey and why is measuring and monitoring is important is to produce newest informations about the land or the earth's surface. And bear in mind that we do have our land use data, land use map, but unfortunately, it is quite difficult to have the latest data because of the difficulties to produce it. That's why it's very important we can have specific systems to keep updating all of these land use changes so that for the development, also the planning of the urban, it could be either physical or it could be the social planning can be done. And why we do this is because to cope up with the increasing of the world population, as we know that now world's already we do have about 7 billions of population, and also the increase of the land value, the dwindle or diminishing of the natural resources, and the deteriorations of the quality of the natural resources, which is our land, water, and air, right? So these are one kind of the surveys with the modern theodolite using the GPS. I mean, you ever use this during your school's field course? Even though some of you might, yeah, not really use it well, wrongly use it. I'm sorry about that. And the reasons for change by through using the technologies is because new tools will help to compute and display and disseminate informations, as well as the increased concerns about the environment locally, region, and globally. And this has a great effort in monitoring, manage, and regulate the use of our land, water, air, and other natural resources. And also, it is a great demand for the new spatial related information. I mean, this data is sellable, this data is commercial, and is it also give a good money on it. So what are the challenges we have during the survey and mapping? Okay, so the challenges is to map the earth above and below the sea level, which is until now is quite impossible, to prepare the navigation charts, to establish the property boundaries of private and public land, develop data banks of land use. This is the common problems that we do have, not only in Malaysia, but also in developed countries. Bear in mind that until now, we don't have any updated land use map by the authority. The latest one will be 2010 in Peninsula Malaysia. For Sarawak, I'm not sure, right? And what are the geometric disciplines? A lot actually. Control survey, topography survey, land boundary and cadastre survey, hydro survey, survey, civil engineering works, mine survey, GIS and remote sensing, and a lot of other disciplines that do use the mapping and as well as GIS. And now we also venture in the archaeology, we will have our geography and many more. So what are the survey organizations in Malaysia? We do have a Department of Surveying and Mapping Malaysia, which is ZUJUPEM. We do have our own Sarawak Land and Survey Department, Board of Survey Sarawak, Royal Institute of Survey Malaysia, and Board of the Surveyor Malaysia. Okay, so this is about the introduction about the survey and mapping. So we look into the principles of survey. What are the principles? We do must have the control points, the consistencies of the accuracy, the measurements, the economic scale of the data collections, independent check by other third parties, as well as the maintenance, which is the quality includes the accuracy or error size of a survey will be maintained, and the final product meets the requirement of the task for which it was taken. It could be varies based on the field, such as if you look into the engineering aspect, around 10 centimeter will be suffice. But when we talk about the cadastre maps, we want to make sure that it is really accurate. However, for the social science, we don't really care about the accuracy of the points as long as it can give you the idea of where does the phenomena is happen. So the control points, working from the whole to the part, which is in a genetic order, it could be the stations will be 50 or 100 kilometer apart. However, for the primary and secondary, smaller size will be better. And bear in mind that the accumulation of those errors within each level cannot exceed the higher level, which is the primary or the genetic order, right? So the control, we do have the horizontal network for survey and mapping in Malaysia, which is established by our JUPEM department. And there are two types. One is the MRT 48, Malayan Revised Triangulations, and also the BRT BT 1968 for the Borneo, which is Sabah and Sarawak, as well as Brunei Darussalam. So, what are the technologies used for the establishment of the horizontal control network? There are a lot actually. Before this, they are using the conventional methods of the survey, come up with the regulations, traverse theodolites, and other techniques. However, nowadays, but the use of the GPS really helps to ensure the accuracy and to fasten the process, as well as very economy in scale. And also the consistency of the data. Any survey works must be carried out according to the outline, specification, or required standards, where normally the accuracy is used to set the standards of the survey. Okay? So meaning to say, the map that we created also can give us the expected error for every certain numbers or certain scales given, as well as, and another one will be the economy. So the survey should meet the necessary conditions in the way that it most economic in the term of time, effort, and cost. So nowadays, GPS offers more economical process in establishing points. And another one will be the independent check. It must have a way to check the survey. So there are quite examples here: random error, systematic error, and gross errors, where it could be checked by the surveyor itself or by any third party. And there are field procedures, and also we also can use the desktop process in order to estimate the errors and also to do some corrections. And of course, the maintenance is very important. All the survey data must be recorded and kept in a proper system, and the ground marks will be disappear. So updating of the records will be necessary, right? And all of this record can be viewed from the Department of Land Survey Sarawak, or as well as JUPEM. So these are the implementations of the survey. The first will be to plan and to do some recce, to mark the points and to do data acquisitions. Of course, after that, to do the data processing, to present the data in terms of maps, and to do the remarking or resurvey if they are needed. So that's the end of the LU1. Thank you very much. We will continue to the second LU. Thank you.